this is going to be pretty brief. Chapter 6 was tedious. I think it's definitely the most tedious chapter. So again, I just want to do big picture. What are the things that you learned? And the first thing that we learned was to identify differential equation, prove solutions of differential equations. That doesn't make a very good multiple choice test question. So kind of go straight to section 2 when you're studying, because what's more interesting is to be able to solve differential equations. And let's just recap that process real quick. Let's say I had this equation. The process for solving the differential equation is to use separation of variables. What that means is you get all the x terms on one side, all the y terms on the other side. So it always happens that you're going to take dx, multiply it to the other side. So this becomes my x side. So I'm also going to take this and divide it over, which means I need to move y over to this side. And so I would have 1 over y dy equals, my x can stay there, it was fine, x squared plus 4 dx. So first we've gathered all the y terms on one side, x terms on the other. And then you integrate both sides. And we have plenty of techniques for doing that integration. When you integrate, you have to add plus c. Well, this is just a constant, right? So I can move this constant over here and it just becomes another constant. So you only have one c that you have to worry about. So when you solve this, you'll go on and solve for y. So you get y equals blah, 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 x, blah, 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 plus c. This is the general solution. Later we're going to look at slope fields. We see that there's all kinds of solutions, right? This is the general solution. You have to have an initial condition to solve for c. So somewhere in the problem, it's got to give you some xy coordinates. It's got to give you a data point for you to plug in x, plug in y, then you can solve for c. That gives you the particular solution. So the general solution stays in terms of c. The particular solution, use a coordinate point and solve for c. Get a number for c. You should be able to interpret those sentences that say something like, the rate of change of A is proportional to A. And remember, a rate of change is always something dt. And I think I just said the rate of change of A is proportional. So is where my equal sign goes, is proportional, so there's your proportionality constant, to A. So again, the original statement that I said was the rate of change of A is proportional to A. The rate of change of A is proportional to A. You should be able to take that statement and write that equation. And you've solved this numerous times at this point. You know that the solution of this becomes your exponential growth and decay function. And just things to remember about that. This is your initial amount of the population, whatever it is you're talking about in the problem. This is your initial amount. This is the amount after some time t, and then that's your growth or decay constant. If the population is growing, it's positive. If the population is decreasing, then that is negative. And there's just a lot of tedious algebra, solving the problem. Main thing to remember is you've got to isolate that exponential term, so you have to divide c over. Once that's out of the picture, then you can take the natural log of both sides, and that's how you get those out of the exponent. Just lots of tedious algebra. And then speaking of tedious, we've got those slope fields. So remember, a slope field is you've got some dy dx expression, you've got some equation here, and then this is where you kind of make your table, and you start picking coordinates. I want the origin, I want this point, I want this point, and you plug those x and y coordinates in to your equation. In this case, we didn't have any y terms, that's okay. What dy dx is telling you then is the slope, right? So if I get 0 slope, if I get a slope of 1, if I get a slope of 2, if I get a slope of -1, and then you sketch all those coordinates, you'll have some layout here, and you take those things that you plotted and you sketch them. Don't have a specific example here, I'm not actually working anything out, but you get the idea. We've done this. That makes a very difficult multiple choice question as well. You might expect to do that on a free response question. For multiple choice, it's far more likely that you'll have to match. You'll have to match the differential equation to the slope field, and that's where you're looking for patterns, things that you should be looking for. Asymptotes are always a big one. Remember, asymptotes happen where your denominator is equal to 0. Look for shapes that you're familiar with, like sine waves. We know what those look like, or exponential functions. We know what those look like. And then I always like to look for places where the slope is 0. If I have a slope field that's doing this, that's a pretty distinguishing feature, and I might go look through my choices and see if there's anything that's going to consistently give me a slope of 0 at whatever that x-coordinate is. So look for those distinguishing features, and then, if all else fails, process of elimination. You can always pick test points, plot some test points, and see where your plot matches what's given to you. This is a shorter test. It's only going to be 20 questions, and I don't think you'll have too much trouble with it.